Designed to tackle the challenges within the current foiling arena, which is considered reasonably unsustainable, expensive and elite, the Moth Challenge aims to improve sustainability and accessibility. The University of Southampton's Moth is designed to compete in the Moth Challenge at Foiling Week held in Lake Garda. This is an international student competition which is assessed on design, manufacturing, performance and racing. The design is based on the International Moth Class Association and Moth rules. The GDP project focuses on three components: hull with no more than 20% carbon fibre reinforced polymers, wing bars, ultrasonic flight control system, which the Moth rules have permitted for the first year. The aim of the project is to improve the sustainability and accessibility of a modern moth. These are achieved through the project objectives. After extensive research, flax and glass fibres, PET and cork cores, and bioresins were tested. The influence of water absorption was also analysed by soaking selected specimens for 5 days. Flax fibres were laid into the second-hand hull mould either side of a PET core and was then infused with infigreen bioresin. The bulkheads were cut from one large manufactured sheet made from the flax fibres with PET core. The wing bars were manufactured by bending Sitka spruce plies around a homemade mould. Vacuum infusion was used for manufacturing the hull shell, bulkheads and deck, whereas wet layup was used for the wing bars and secondary bonding. The stiffness and the neutral axis position of the hull were measured using strain gauges up to a mass of 100 kilos during longitudinal testing. Deflection of the wing bars was measured using linear vertical displacement transducers with a maximum mass of 90 kilograms at 3 locations. The wing bar testing was repeated with an off-the-shelf version of a Moth for comparison. The results of both tests were used to validate the FEA model for further optimization. Various flax overlaps were laid up with the bulkhead composition to investigate the optimum width. The width of the overlap was found to be irrelevant as the PET core failed before the skin. Flexural and tensile testing showed the cork core was favoured and that there was little difference between the two bioresins. The team seized the opportunity to develop an ultrasonic flight control system which was tested in the Boulderwood towing tank and compared against a traditional one system. In regular waves, the sensor is able to compete with the traditional system and even outperform it with regards to wave response. However, irregular wave results show some disadvantages and offers room for improvement. Our Moth is now ready to compete at the Moth Challenge 2022. Thank you to all our sponsors and supporters for making this possible.